Alright, so when we're talking about the inverse function, the inverse is often thought of undoing or reversing a position, order, or effect. So think of wrapping a present and then unwrapping a present. Those are reverse operations or reverse effects. So if you think of adding, what's the opposite of adding? Right, those are inverses. Multiplying, the opposite is? Good. If you square, what's the opposite? Square root. Good. So those are all inverses of one another. It's the opposite effect. So you guys have actually been dealing with inverses for as long as you've been dealing with equations. Because whenever you have an equation and you get x by itself, you undo the equation to get the x alone, which is basically doing inverse operations. So now that we're getting into functions, the inverse is still doing the opposite. But when we are dealing with functions, the opposite of x would be, what's the opposite of x? Y, right. So x and y, by switching them, we create an inverse function. So you don't have to write this down, we'll just take a look so far. So if I want to change a function into its inverse, the function I'm starting with is y equals 2x plus 1. So what I would do first is I would switch x and y. So I'm going to actually switch the x and y. Because by switching the x and y, now I've done the inverse function. But an equation should never be x equals, it should always be y equals. So now I'm going to undo the equation until I have y by itself. So I'm going to subtract the 1. So I get x subtract 1 equals 2y. Divide the 2. So we're going to get x minus 1 divided by 2 equals y. So that would be my inverse equation compared to the original. When we write inverse, we say -1 as an exponent. That again means the inverse equation. So we'd say the inverse is x minus 1 divided by 2. So these are just some notes from your booklet. It says any set of ordered pairs we call a relation. The inverse of the relation has the symbol, again, f with that -1 as the exponent. That's the inverse symbol. It's found by switching the x-coordinate and the y-coordinate. So if the pair AB is on a relation, then the inverse would be the pair BA. So when we look at some points here, if I wanted to come up with the inverse of these points, all we do is switch them. So the point 2 and 8 becomes 8 and 2. The point 1 and 1, when we switch them, still is 1 and 1. This is in your book, you can write this down. The point -64 and -4, again, we switch them. And then -1,000 and -10. So again, in the inverse set, we switch the x and the y values to create the inverse. Next thing you have to be able to do is find the equation of an inverse function. So we just did that before. So step 1 is you're going to switch x and y, and then you're going to solve for y is step 2. So the same 2 steps every time. So let's look at part A. Here's our equation, y equals 4x minus 8. Step 1, switch your x and your y. So it's going to be x equals 4y minus 8. Step 2, we're going to solve the equation so that the y is alone. So I'm going to add the 8 over. So I get x plus 8 equals 4y. And then divide out the 4. So my inverse is going to be x plus 8 divided by 4. Now I want to show you one other way that you can write this. Since the whole thing is divided by 4, you could also write that each part is divided by 4. So it would actually be 1 over 4x plus 2, because 8 divided by 4 is 2. So you could say x over 4 plus 2, or 1/4 x plus 2, but I'm just trying to show you that there's a few different ways that you could write this. If you wrote x plus 8 divided by 4, full marks as well. Okay? Sometimes your textbook will make it look a little bit different in its answer key. So this next equation has a root in it. So we're going to start same process, switch your x and your y. And now we're going to work to get the y by itself. So first of all, there's that square root that needs to be dealt with. How do you undo a square root? Square both sides, good. So we're going to get x squared equals 2y minus 4. Then we're going to add that 4 over. And then we'll divide by that 2. So again, this could be x squared plus 4 divided by 2 for your inverse. Or you could say that that's x squared divided by 2 plus 2 if you divide the 2 to each section. So here we're going to graph the inverse of this and then state the domain and range. So first of all, my original graph, I'm going to actually write this as ordered pairs. So my first point here is at -6 and +4. My next point is at -4 and +6. My next point is at 0 and 6. And then I've got a point at 2 and 2. And then my point is at 4 and 2. And then at 6 and 0. Okay, so I know these points are all part of my original graph. Let's also do the domain and range of the original graph right now. So when I look at the x's, which are part of the domain, it goes as low as -6 and as high as +6. So we say that the x's are all in between -6 and +6. The range goes as low as 0 and as high as +6. So it goes as low as 0, as high as +6, and all the y's would be in between 0 and +6. So now to graph the inverse, we need to switch the x and the y values around. So this point's going to become 4 and -6. So +4 and -6 would be down here. So we're just going to switch the x and the y values for each coordinate. So you should notice here that we have one invariant point, and that's at the point 2 and 2 right here, because that point did not change. Now let's also look at the domain and range. There was another good comment that said, so the domain and range are switched? Let's take a look. So here my domain values now go from 0 to +6. So my new domain goes as low as 0 and as high as +6. And my ranges now go as low as -6 and as high as +6. So the comment that said our domain and range have also switched is correct. And that should make sense. If your x's and y's switch, your domain and range have also switched because those are x's and y's. So I'd like you then to just pause for a minute and please try page 51, number 2 and 5 before moving on to our next examples. Alright, so here's our next example. It's the inverse graph is always a reflection of the graph in the mirror formed by the line y equals x. So what that means, you guys, is that the line y equals x is a line where every y value and every x value are equal. So it would be a diagonal line that would run straight through where all your y's and x's are the same. Notice that your invariant point of 2 and 2 lies on that line of reflection. So an inverse is a reflection, but it's reflected over the line y equals x. So it's reflected diagonally. So if we try this example, here it's saying that our graph f of x is this darker blue graph, and then it's also giving us the line of reflection, the line y equals x. So not only can you just switch points, you could also take the method of actually reflecting it over the diagonal line. I do think it's easier to take coordinates. So if you look here, this coordinate is at 0 and 6. So where would your new inverse graph lie?
6 and 0.
6 and 0. So it would lie over here at 6 and 0. Notice though that that has been reflected. If you look about how far it is here from the line of reflection, it should be equal. Let's also take another point. And when it's linear, another easy point then would be your x axis. So this one's at -3 and 0. So your new graph would be at 0 and -3. Now since it's linear, all we have to do is then connect the dots. Alright, the final thing we have to look at is if our graphs are functions. So sometimes when you create an inverse graph, it is no longer a function. Remember, for something to be a function, it has to pass the vertical line test. So if we look at the graph here that's on the board, to pass the vertical line test, that means anytime you draw a vertical line, it only hits the graph in one spot. So to pass the vertical line test, anytime you draw a vertical line, it'll only hit your graph once. So just for a non-example, if you had a shape like this, and you drew a vertical line, it would hit more than once, so that would be not a function. So to be a function, a vertical line can only hit at one spot. So when we look at the blue graph would pass the vertical line test. So we'd say, yes, it is a function because it passes, I like to call it the VLT, the vertical line test. But if you look at the inverse, the red graph, the inverse is not a function because it fails the vertical line test. Oops, that should say T. So it fails the vertical line test. And again, if you made a vertical line through that red graph, it would hit 3 times instead of just once. Now, here is kind of the big idea that's new for today. Okay, so we're now going to introduce the horizontal line test. So you guys know that a vertical line runs up and down, a horizontal line runs left and right. So you can skip the step of drawing the inverse to test the VLT by applying the horizontal line test to the original function. So if I look back at my original function and I draw a horizontal line and I see that it fails because it hits 1, 2, 3 times, then I know that the inverse is not a function. So again, the vertical line test tests a function that you have, but you can check if the inverse is a function by applying a horizontal line test to the original graph. Alright, so for your textbook assignment, please complete number 2, 3, 5, 9, 11, 15, and 16.